Hi, this is Asing. You are now watching Asing Math TV. Today we'd like to share how to solve this complex equation. Based on the equation, we should have 4z squared minus 2z plus 1 is equal to 0, or z to the power 4 minus 4i cubed is equal to 0. Let's solve for the first equation. Since it is in the form of quadratic equation, let's apply the quadratic formula. Recall that the quadratic formula states that the root is equal to minus b plus minus square root of b squared minus 4ac divided by 2a. Based on the equation, a is equal to 4, b equal to negative 2, while c is equal to 1, which means that z is equal to 2 plus minus square root of 2 squared minus 4 multiply 4 multiply 1 divided by 2 multiply 4. And this is equal to 2 plus minus square root of negative 12 divided by 2 multiply 4. As we know that negative is equal to I squared, so let's change it, while 12 is equal to 3 multiply 4, and the whole thing we should divide 2 multiply 4. Let's simplify. We should have 2 plus minus square root of 4i squared is equal to 2i, and we left 3, and the whole thing divided by 2 multiply 4. Simplify, we should obtain 1 over 4 plus minus 3 divided by 4i. And now let's convert to exponential form. Firstly, let's determine the modulus of the complex number, that is square root of the sum of square of the xy components. There are 1 over 4 square plus 3 over 4 square, and this is equal to 1 over 2. Next, let's determine the argument, that is arctangent of the ratio of y-x components. So we should have 3 over 4 divided by 1 over 4, which is equal to arctangent of 3, and this is equal to pi over 3, which means that the solution for this complex number is equal to 1 over 2 e to the power of plus minus pi over 3i, or we can write separately, that is negative pi over 3i, and also for the one positive pi over 3i. Next, let's solve for the second equation. I'm going to first rewrite the equation. We should have z power 4 is equal to negative, bring over to the right hand side becomes positive, and I cube is simply I squared multiply I, and we know that I squared is negative 1, so we have 4 multiply negative 1, which is negative 4, and I remain. If I let w be equal to negative 4i, which means that the modulus is equal to 4, and the argument is equal to arctangent, since we do not have the real part, which means that the x component is equal to 0. If the denominator is equal to 0, regardless what is the numerator, we will obtain math error when we pressing the calculator. So to determine this angle, we can make use of the Cartesian plane with xy component. From here, w is equal to negative 4i. More precisely, we should have 0 for the real part, while the imaginary part is negative 4i, which means that the xy component is 0 and negative 4. That is somewhere around here. If we draw the angle starting from the origin and up to this point, we should have 270 degree, or equivalently negative 90 degree, which means that the argument is negative pi over 2. Therefore, w is equal to 4 e to the power negative pi over 2i. However, what we need here is z, so which means that the solution is equal to w to the power 1 over 4. To obtain the solution, very easy. Firstly, take the modulus to the power that we have, that is 1 over 4, and this would simply set to. Next, with the explanation, we have e to the power negative pi over 2i. However, we need to take root of 4, which means that we should take the power divided by 4, that is pi over 8i. And now let's determine the rest of the solutions. To find them very easy, recall that one complete circle we should have 2 pi, but what we need here is 4 solutions, so it should be divided by 4 and we obtain pi over 2, which means that the gap or the angle in between the complex number is pi over 2. In other words, to determine the next solution, we should increase the angle by pi over 2, so we should have negative pi over 8 plus pi over 2, that is 3 over 8 pi. Don't forget the imaginary number. And the next one, again increase by pi over 2, and we should obtain 7 over 8 pi I. And for the last solution, again we should increase the angle by another pi over 2, and we should obtain 11 over 8 pi I. However, since the question mentioned we should use principal values of their arguments, which means that the range should within negative pi to positive pi. So whenever we have more than 8, we should minus 2 pi. For the first 3, since within the range, that is negative pi to positive pi, this we do not have to perform any calculation. We can copy exactly what we have. But for the last one, since it's more than pi, so let's minus 2 pi, and we should obtain negative 5 over 8 pi with I. Therefore, the complete solutions of the equation is equal to set to e to the power negative pi over 8i, 1 over 2 e to the power negative pi over 3i, set to e to the power negative 5 over 8 pi I, 1 over 2 e to the power pi over 3i, set to e to the power 3 8 pi I, and last one set to e to the power 7 8 pi I, with increasing order of angles, and hence we done. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.